Okay, on this problem we need to solve the equation over the interval 0 to theta is over 0 to 2 pi. So when you have that, you know you're in radian mode. So make sure your calculators are in radian mode. So if we did not have a calculator to start, I would look at this. That is a quadratic. So I'm going to solve that as a quadratic. So 2 cosine squared theta minus cos theta minus 1 would equal 0. Quadratics are factorable. So let's test this out. I've got 2 cosine theta and a cosine theta. And I've got ones and ones, and I got to get a negative, so it would be negative 2 plus 1. So now you are looking for, that's a little messy there. Now we are looking for what makes each of those binomials 0. So you have to set each one of these equal to 0 and solve. So you'd have 2 cosine theta equals negative 1. So cosine of some angle is negative a half. So the cosine of any angle is negative in quadrants 2 and 3. That is not the ratio from a special 30, 60, 90, 45 triangle. So we would go to our calculators and input this. Make sure you're in the radian mode. You would input inverse cos of negative 0.5, and your calculator spits out the answer 2.094. Well, that's only one quadrant, and that's in quadrant 2. So how would I get the quadrant 3 answer? You would go, quadrant 3 answer is pi plus 2.094. And those are your two answers to theta for that first part. Now you still have this guy right here. So we have to go cosine of the angle is 1. And where does that happen? Only in one spot, and that is at 0 radians. So those are your 3 answers over that interval. There are obviously infinite answers, but we were given a specific interval 0 to 2 pi. Okay, this requires your knowledge of graphing. These usually come in y equals a cosine or sine bx, where a is your amplitude and b has to do with your period. So the amplitude for this one is 2, so you know that is plus or minus 2. There's no shift because there's no addition or subtraction on your x and y terms. And the period is equal to 2 pi over whatever b is. So I have 2 pi over 2, which is pi. So what that tells me is every pi radians, I have one cycle of this function with a height and a depth of 2. So let's see what this looks like. So let's see if I can get a cycle going here. Normally a cycle would be every 2 pi radians because b is usually 1, but since b is 2, I have for every 2 pi radians I have 2 complete cycles of the cosine wave. So if I label this as one complete cycle is going to be through pi, you'd break this into four pieces, and I've got a height of 2 and a depth of 2, and cosines always start at 0, and then they go down to 0 in the first quadrant and down to, that would be a negative 1, but we're at negative 2, back up to 0, and then back up to 2. So this goes, and remember this, it's continuous. So I've just sketched one cycle of a cosine wave through pi radians. Okay, first of all, I'm going to take this picture, which is a little small for me to draw on, and I'm going to enhance it a little bit. We got a plane flying at 35,000 feet. And here's my plane. Flying at 35,000 feet, and it sees a town, we will call it town A. And then it sees another town B off in the distance. And the town B that he sees off in the distance has an angle of depression. Angle of depressions go down. So the first one is at 32 degrees. And the next plane he sees, or town A he sees at 76 degrees. It's a little messy, but hopefully you can get the gist of that. So if that is 76, then this one right here is 44. And since that whole angle from the plane to the elevation is a right angle, we can say that this angle is a 14 degrees. All right, so the question is, what is this? The distance between these two towns. In order to do that, probably several ways to do it, but I'm going to do law of sines, and I'm going to work on this first triangle up here. So I'm going to pull pieces off of that. And this is town B down here. And this is the 35,000 feet on that side also. And if this is 32, this must be 58 because we know we have a right triangle. So I want to find this edge right here. So if I want to find that leg of that triangle, I'm going to use law of sines, and which sets up as sine of 32 degrees divided by the side that it's looking at, which is 35,000, equals sine of 58 degrees divided by the other side, x. If you do that math, you get x equals 56,011.709 feet. So now we have x and we have that other side, which is what we need. Now let me pull off the other triangle, and I'm pulling off that other triangle with town A attached to it. I'm going to go into this picture a little bit. This is 35,000. We determine that to be 14, and I'm going to be looking for this length, because if I find y, and I just found x up here, the top piece of that triangle, of that rectangle, if I just subtract y from x, then you would get the length from town A to town B. So I'm going to do law of sines again. So the sine of 14 degrees divided by the side is equal to, now I'm going to need this angle right here. Well, if you know that there's a 76 up here, and you've got a two parallel lines and a transversal that goes through it, this being the transversal, the one I'm highlighting. If you have a transversal that goes through there, then you know that you have alternate interior angles, so this must be a 76 degrees. Or you could just subtract 76 and 14 need to add up to 90, which is an easier way to do that. So the sine of 14 over y equals the sine of 76 over that huge number, 35,000. And if you do cross products on that, you get y is equal to 8,726.480 feet. Notice I'm going up to 3 digits also, 3 decimal points. The AP exam requires that you do go out to 3 decimal spots or more. So now I have that side being 8,000. This y is 8,726.480. If I subtract that from 56,011.709, you get the distance between those towns, which is z, equals 47,285.229 feet. And we have just finished that problem using law of sines.